Hi everyone, let's take a look at number 15 on page 129. The position-time relationship for a moving object is given by S of t equals to kt² plus, open bracket, 6k² minus 10k, close bracket, times t plus 2k, where k is a non-zero constant. A, show that the acceleration is constant. B, find the time at which the velocity is zero and determine the position of the object when this occurs. So I'm going to divide this into two different columns, starting with part A, and I'm going to copy S of t. So in part A, they're asking you to show that the acceleration is constant. So the first step is to find the velocity before we can find the acceleration. Velocity, by definition, is the derivative of displacement. So in this case, v of t equals to 2 times k times t plus 6k² minus 10k. Again, that last part, because 2k is a constant, the derivative is 0. So again, I'm adding 0 just for your understanding. You don't have to really show this. Step 2. To find acceleration, you have to find the derivative of velocity. Or, if you're starting from the beginning, you're really finding the second derivative of displacement. So in this case, a of t equals to 2k. And again, 6k² minus 10k is a constant. So when you find the derivative, that becomes 0. So acceleration equals to 2k, which is basically a constant. Part B. Find the time at which the velocity is 0 and determine the position of the object when this occurs. So the first step is to find time when velocity equals to 0. This means in math, v of t equals to 0. Now from part A, we found the velocity. So we're going to copy 2 kt plus 6k² minus 10k, and we set this to 0. Now to solve this, you have to bring everything to one side. So I'm going to keep 2kt to the right. I'm going to bring 6k² minus 10k to the left, which becomes 10k minus 6k². The opposite of multiplying by 2k is to divide by 2k. So now time equals to 10k divided by 2k, that's going to be 5, minus 6k² divided by 2k, that's 3k. So the time equals to 5 minus 3k. And of course, k cannot be 0. Now, the second part of part B is determine the position of the object when this occurs. So it goes to find S of t, except t in this case is going to be 5 minus 3k. So to find this, I go back to the given and I plug it in. So again, we were given S of t, except now we're going to plug it in where time equals to 5 minus 3k. So this is going to be k, open bracket, 5 minus 3k, quantity squared, plus open bracket, 6k² minus 10k, times 5 minus 3k plus 2k. So when you expand this and you collect like terms, this gives you k, open the bracket, when you expand a perfect square, 5 squared is going to be 25, minus 2 times 5 times 3k, that's going to be 30k, plus 3k in brackets, square, that's 9k², plus, if you expand the product of the two binomials, 6k² times 5, that's going to be 30k². Now, if you look at the next term, it's going to be minus 18k cubed minus 50k plus 30k squared plus 2k. Now, if you expand the first part, that's 25k minus 30k squared plus 9k cubed. Now you can collect some like terms, 30k squared plus another 30k squared. That's going to be 60k squared. So again, you can cross these out to stay organized. Minus 18k cubed negative 50k plus 2k. That's going to give you negative 48k. Here comes the final answer. Negative 9k cubed. Now again, you can go back and cross this out. So 9 minus 18, that's negative 9. Likewise, plus 30k squared. So if you go back and you take negative 30 plus 60, that's 30 minus 23k. And again, that's from 25 minus 48. So I hope this makes sense.